Welcome, everybody. My name is Jordi Ricard, and it's a pleasure to introduce this first session of our Journey to the Cloud series. With that, it's my pleasure to hand over the session to Oscar Martinez, head of our Big Data and Cloud practice. Oscar, can you introduce the series of webinars we are starting today?
Thanks, Jordi, for the introduction. Yeah, as Jordi said, this is the first session of this series. In this series, we are going to be talking about the main technological options you have for creating your data platform on the cloud. Today, the first session is about Azure. Our next session will be in a couple of weeks, and it will be about Google Cloud. The third session, it's already planned after the summer. It's going to be on the 14th of September. And then later on this year, or maybe it will move to the next year, we will also feature sessions on Snowflake, Dremio, and Cloudera. Those are the main 6 options that we are nowadays developing. There are others that we might also have on standalone sessions. Like, for example, we are also very strong on building data platforms with Oracle. So that might be that we have a dedicated session also, like a 7th session on Oracle. But we didn't want to fill this slide with many options. For the ones that we are planning for now are the first 3, and the next will come later. Azure is the one that we will be covering today. So Google Cloud, Azure, and Amazon, as you guys know, are the main cloud providers, and they all have their own native services for building data platforms. In Azure, as we will see today, we will be focusing a lot on Azure Synapse, which is probably the cornerstone of building a modern data platform in Azure. In Google, we could say similarly, the cornerstone is BigQuery, and we will be covering that in the next session. In Amazon is a platform where there are many services to do it. Redshift is the equivalent, though it's a bit different in the approach they take to implement Redshift. And we also have many services there, Glue. We also have managed Airflow and many others that we will cover. Then Snowflake is it's a cloud data warehouse built only for cloud, that its main purpose is to do as a data warehouse. It has evolved into the Lakehouse. Today we will also be talking about Lakehouse. Snowflake is as an option to build a Lakehouse. Similarly to Dremio, but Dremio is a query engine for querying data lakes, but also evolving into a Lakehouse. And finally, Cloudera. Cloudera, I think everyone knows Cloudera is a box that contains many different services, Hive, Spark, Impala, and you name it. And it's very, very common to find Cloudera in hybrid scenarios where you have a bit of your platform on the cloud and a bit of the platform on-premise, and Cloudera has features for both of them. So without further ado, I will now leave you with Manuel, who will be driving you in this first journey to the clouds with Azure. All yours, Manuel.
Thank you, Oscar. Let's begin with the modern data warehouse with Azure Synapse introduction and demo. I am going to explain you how Azure Synapse works, a high-level introduction, and then I will, at the same time that I am explaining the different slides, I will demo, and we will begin. We will demo an end-to-end solution. We've prepared an interesting demo, a quick demo, on how to set up or build a modern data warehouse with Synapse from scratch and consume it with Power BI. So what's Azure Synapse Analytics? Basically, it is an integrated analytics data platform which combines data warehousing, big data analytics, data integration, and visualization into one single environment. It is like a Swiss knife for building modern data warehouse because it allows us to convert any type of data into information and at any scale, no matter the volume. It provides tools code-free like data flows or code first, like we can write PySpark notebooks. So depending on the task and the skills of our team, we can choose among different tools and programming languages. We can forget also of complex integration tasks if, for example, if we need to make use of the integrated Spark pool or Azure Databricks for advanced analytics, particularly for those who come from traditional BI, like me, it is important to highlight the SQL runtime, provisioned or on demand. Okay, so this means that we can use our data warehousing techniques and knowledge, but in a flexible environment, ready to handle more complex scenarios. No matter if we begin small, we will make use and pay only for the resources we need. So this is a high-level introduction, a high-level diagram of the Lakehouse architecture. We have the different data sources, real-time, IoT, on-premises, cloud, all these data sources. We can ingest them easily with Azure Synapse. The first layer, this architecture, the key point to understand this architecture is that we put in the center a data lake. This is the main difference between the traditional architecture. Instead of working with relational databases or so, we have a data lake. This is the main point to understand this kind of modern data warehouse. The data lake allows, in this case, Azure Data Lake Storage Generation 2 allows us to store the data in files instead of relational database. And it is a low-cost storage solution that contains a set of capabilities dedicated to big data analytics. What I am going to demo is we are going to ingest data from an on-premises SQL server. We have several 70 tables, more or less, we are going to ingest in data files. So the first layer is the extract load ingestion, and we are going to store the files in the browse layer. This is the raw data without any transformation. Then we are going to use the SQL runtime to transform this data and make it query ready. This is for the silver layer. We are going to standardize this data and to make it query ready. We have different tools to make this. We have the no code mapping data flows. We can use our knowledge of SQL, or we can use the Apache Spark cluster or the Azure Databricks to transform data. But in our case, to speed up the demo, we are going to use the SQL engine. At the end, the last layer where we are going to store the information is the goal layer. We are not going to use the pure, the 100% data lakehouse approach. We are going to store the fact tables and the dimension in a SQL pool. So the SQL pool in this case is going to store the goal layer, and at the same time is going to serve this data to Power BI. So this is the demo I am going to make. More things interesting from this slide is that we have this is the Swiss knife. We have everything in one place. We have direct integration to Git on the Azure DevOps. Here in the top, we have integrated security, the Azure Active Directory, the Security Center, the Azure Monitor to monitor everything that is happening inside Synapse. And finally, we have integration with Purview, the data management and governance tool that Microsoft lets us, brings us as the proper tool to do this kind of task. So for the first layer, we are going to do the ingestion. For the ingestion, we are going to make use of the Synapse pipelines. We are going to use Azure Data Factory that is inside Synapse. We call it Synapse. It's called Synapse pipelines. So it's the perfect tool for ingesting data from on-premises, hybrid, multi-cloud. It has lots of connectors to ingest the data very easily. And the interesting thing of this tool when we are working with enterprise projects with lots of data sources and lots of entities to ingest is that it brings us a metadata-driven approach. So it's a tool that allows us to build dynamic pipelines that will use the metadata stored in a control table. This metadata contains the name list of the tables to copy with our required synchronized pattern, like full or incremental. So it's a built-in framework that acts as an accelerator to our development efforts. And at the same time, it helps reduce the number of pipelines and tasks to maintain. So let's jump to the demo to understand this first ingestion layer. As I have explained to you, we have on the one side, we have our SQL Server. It's a local host with the AdventureWorks database. You can see we have several 70 tables to ingest data. We are not going to develop one-to-one package to copy this data. So the first thing we are going to do is to ingest data, and we are going to use this metadata-driven copy task. As you can see, the first thing it asks us where is the metadata table to store the metadata that will read from Synapse will read from our data store, in this case SQL Server. So this is the main control table. The next step, okay, we are going to use which is the source type. As I have told you, there are more than 90 connectors, so we can connect basically to everywhere. In this case, we are going to use our SQL Server on premises. As you can see, it's just I have the linked service connection. It is now connecting to the gateway, and it's reading all the tables. At this point, we will see the near 70 tables that we are going to select to ingest. I want to ingest all the tables, except these 3 tables that they don't have any information. And the next step, okay, let's go to the next steps. We can configure individually each table or always perform a full load of tables. Okay, we have the 2 flavors, the 2 synchronized pattern, the full load or the delta load. Okay, we can do configure an incremental delta load. For this demo, we are going to use the full load for all the tables. We are not going to configure an incremental load. And the target, as I have explained, will be our data lake. Our data lake will store this the data from these tables in a raw file using a specific format. So now it's reading all the metadata, it's connecting to our data source, is validating that everything is okay, and our target type is our data lake. Okay, I have this connection. We have to choose where we want in our data lake to store these data files. We have created in our Azure Data Lake Storage Generation 2 the raw layer or the bronze layer. So we are selecting this. Second, I don't want any suffix for this. Second, let me select the data lake folder. It's here, data lake, raw, and we are ready for the next. Come on. Let's go to the next. Let's choose the Parquet file, a file format that is ideal for big data, to store big data and not big data data in files. Let's call it the on-prem to pro. Let's call the pipeline this name. So, and here we have we can review. So we are connected to a SQL Server and we are ingesting to data lake. We see here summary And then it is going to deploy in the next step the pipelines, and it is going to generate the script to insert the table in our main control table, the metadata table. I'm going to start to discard the changes. I have this prepared. We have this pipeline, the on-premises to row. As you can see here, it is a pipeline. We are going to put this in action in order to ingest and populate our data lake. So what it is really this doing? As you can see, it's only one pipeline with 3 levels, with the bottom levels. And what this is doing while it is ingesting the data, basically it is reading all the metadata contained in this main control table. This is containing the 65 tables. In this case, that we are going to ingest data. So it's the source. It contains the source table that we are going to read from our SQL Server on premises, and information about the destination, okay, which is the sync file name, the sync folder path. So everything that is basically the pipeline is reading the information of this table, and it's performing the ingestion of all these tables. We can enable or disable from this table without the need of changing or programming anything. So let me check if this is debugging. Perfect. This is in progress, and we will see that the data is being ingested. As you see here from the Azure Data Lake, we have from Azure Synapse, we have the data lake connection. We have our data lake storage connection, so we have everything integrated. We can see how the data is being ingested in real time in our data lake. So we have here you can see the different tables, the different files. We can order, and we can see the different. So once the data is ingested, we have to make use of the SQL serverless pool to analyze this. So at this point, okay, we have the pros layer. We have to convert this data that is here in the pros layer to make it available query ready. For this demo, what we are going to do is to make use of the SQL Flower and make use of the SQL serverless pool that it brings us a SQL Server look and feel. Is like analyzing querying data, but the underlying data is not in a relational store. It is the data lake. This means that we can query the data lake from Management Studio or from any tool, like if they were tables. Okay. So at this point, we have with the metadata. Let me show you this how this serverless pool looks like. This is our serverless. I am connected from Management Studio, and I have deployed here different views. Okay, so if I want to query, for instance, the sale customer view, the sale customer file, what I have here is the sales customer file. It's here. You can see that it's here. I can query this file using Management Studio. I can do this inside Azure Synapse as well, and we can query the data lake as if it was SQL Server. But in reality, behind the scenes, we can see that we are querying the data lake. Okay, so this is the underlayer data. So it is using the function open row set to query in the format bucket our sales customer file. Okay, so this is how we have this silver layer with SQL. It's easy. It's a virtual layer. In this case, we are not storing. We could make use of external tables, but for demo purposes, we are using just silver views. And the next is the gold layer, where we have to perform we are going to build the dimensions and the fact table. At this point, it's just a quick introduction of what is the Delta Lake. Okay, so Delta Lake is a format for the data lake. That it is the key let's say the key option that will let us build our data warehouse over a data lake. Okay, because one of the main problems is that it is not possible to do updates or deletes over Parquet files. The Delta format lets us apply this kind of operations over Parquet files, and it provides easy transactions to the data lake, the same way we would do in a database. It is important to clarify that the term Delta Lake refers to a data lake with the Delta format. Azure Synapse Analytics provides us the tools needed to implement the Lakehouse pattern on top of Azure Data Lake storage. So we can make use of different of the mapping data flows, Azure Databricks or Apache Spark to write this in the Delta Lake format. The SQL is runtime is excluded because it can read Delta format, but it cannot write over the Delta Lake format. Okay, so let's go to the goal layer. Let's finish our data warehouse. So once we have our data ingested in the data lake, we have this data is already ingested. We are going to, it's almost finished, or I think it has finished. What we are going to build are, I have prepared some views here. So I have created here some views to create the fact. It's also virtual. So we are adding the transforming the data, adding additional columns. So converting the data to a proper format. Okay, so doing several joins. So this kind of logic can be embedded in. We are doing using the SQL, and we have here these views. I have created these views over the Parquet files that are stored. It's also virtual and is using these views, as you can see here. So it's like a SQL server, as I have told you. And we are going to insert this information. We are going to move to this information to the SQL pool to store in our data warehouse. Okay, that is the SQL pool. We would perform the same way with the ingestion. We would prepare this with this metadata-driven copy task. I have already prepared this, so it's next. And what we have here is another pipeline that is called the Silver to data warehouse. Again, it is reading our metadata. So our data source now it's our serverless. This is what it is doing. It is connecting to these views that we have done here. Okay. So this is the data source now. It's our serverless. That is like a SQL server, and we are going to ingest to the SQL dedicated SQL pool. Let's put this in action, and let me show you how this is working. Okay, so what it is doing this now, it's moving the information to this data warehouse. So here at the end, we will have, it's now creating the tables. As you can see, I am refreshing. It has created already unloaded the team customer. Okay, so we can see we have the dimensions, and we are near to have the rest of the dimensions at the fact table. It is just copying this data, this pipeline. Okay, while this finishes, let me. Okay, we have the fact sales, the salesperson. We are performing the sales data mart. So let's jump again to the next to the next step. Once we have this goal layer, we need to serve a model and put this into Power BI. So the Power BI, it will be the front end, the business intelligence side where we are going to deploy. We have several options. We are not going to take to details, enter into technical details because it has lots of things to talk about this. But we can change the model if we want to deploy the model to analysis services, or we are going to deploy to a Power BI data set in the cloud. They are basically the same. In our case, we are going to use the Power BI data set. We are going to deploy this. As I have told you, we have we make use of Synapse, and we have I have created. We have a Power BI, our Power BI. Let's jump to Power BI, and we have this. We can integrate this Power BI. Let's see, like we have here in the develop. We have a connection. I have created a connection to our Power BI tenant. Now it is empty. This is connected to the workspace. We can connect to several workspaces, and we can begin to develop content from Synapse. Okay, we will see everything. And what's happening here when we say we want to generate a new data model? Power BI is going to Synapse is going to ask us which is your serve. From where are you going to search the data? The serverless pool or the SQL pool? Remember, we have a blog as well explaining the differences. But remember, this is the first. We have used the serverless as the staging and the SQL pool to store the data warehouse. Okay, so we can connect, and I am going to use the data warehouse connection. And at this point, what it is happening behind the scenes is that is making a Power BI that is going to be connected directly to our SQL pool, so to our dedicated SQL pool. Okay, it is the SQL pool dedicated. It's here. Okay, so we can choose directly. The first thing is let me know which data do you want to load, and we can start modeling from the Power BI desktop. I have prepared a demo for this to avoid having spending too much time. So I have here the PBX demo. It's here with all the data already loaded, with the pack sales, with a sales amount. Let's deploy this. Let's publish this to Power BI. In this case, the Synapse demo, and we will see how Synapse knows when this data set with this Power BI data set is deployed to Power BI and is ready to consume. Okay. So got it, success, we are ready. If we refresh the Power BI, we will see the here in our Synapse demo, we have the, okay, here is the data set. And here in Synapse as well, we are going to refresh. Let's refresh this. Let's see how here it is. It's coming. Power BI demo, the Power BI data sets, perfect. It's ready. And now we want to use this data set as if it was an analysis services. Okay, so we are going to open the demo live connection. What we are going to do now is build a dashboard connected with live connection to this PBX demo. Let me connect this, edit. Let me connect to the PBX demo dataset. We are connected to with a live connection if it was a cube. And we can see here we have a dashboard connected directly. We cannot model this. We are going to publish this to our Synapse demo. So we have connected from the Power BI desktop, and at the same time, it's inside Synapse. We can also build Power BI reports at the same time. Okay, so we have an integrated Power BI desktop inside Synapse, so we can build, model, and build new reports inside Synapse without the need of exiting of the platform. Okay, so I am saying the cells from the city, top city, okay, and we can file, save as, demo Synapse report. Okay. So we have done with Azure Synapse, we are able to work an end-to-end, and we are connected to this report. So we have the two reports deployed here, and we can consume the information. And we can see that we are analyzing our data mart from Power BI with no good look and feel, and with all the things that you know about Power BI. And that's the end of the demo I have prepared. Just a quick wrap up conclusions, very quick. I have shown you how to use this metadata-driven approach to build scalable, editable, flexible, and reliable large-scale copy pipelines. Azure Synapse as the Swiss knife, as a unified data platform to make use of anything we need. And we have everything ready for the Petabyte-scale. No matter if we begin small, we can begin small with reduced resources. Then we can scale whenever we need power. We need power for ingestion. We need power to transform with the Spark pool, to compute with the SQL, with the dedicated SQL pool for processing. We can use the different model analysis services, or the Power BI Premium, or Power BI Premium per user. So we have all the needed things to scale, and inside Synapse. That's why we have this Petabyte-scale architecture. Remember, you can go, and we have lots of blogs comparing and explaining what's a dedicated pool. Next week, we will post a blog explaining this Lakehouse architecture with Synapse, okay, a pure Lakehouse. So you have very interesting blog posts. So this is the end of the demo.
Thank you very much for attending. It was a pleasure. Thank you, Manuel. Thank you, Oscar.